Hi students! These are the describing matter notes, which actually correspond to Chapter 1, Section 1 in your textbook. So it's actually the very beginning, if you want to reference the textbook. It's the very first part of it. And in this section it has some words that you already know, like matter. We've obviously talked a lot about matter so far this year. But then there's other words in here that you have not seen before, so we're going to start to define them. So matter, obviously, is anything that has mass and takes up space, but we're going to describe matter in more specific terms in this unit. So one of those terms is a substance. So a substance is a single kind of matter that's pure, and it always has the same composition no matter where it comes from. A good example of this is salt. Salt. Because there's a couple different places that you can get salt. You probably have heard of sea salt before. But you can also get salt from a mine, so you could get mined salt from the ground. And even though there's two different types of salt, they are both composed, they both have the same composition. They're composed of the same materials, which makes salt an example of a substance. A physical property is a characteristic that can be observed without changing the material into a new substance. So physical properties are often things that you might initially notice when you look at any material. So when you observe some matter, you might initially notice its color. Color is an example of a physical property. Its size, its shape. Once you feel matter, you will initially notice its texture. Some other examples of physical properties are the materials freezing or melting point. So you will remember from when we first learned about freezing and melting point that when we freeze a material and we melt a material, we don't change it into something new. So these are physical properties, freezing point and melting point, because if we freeze or melt water, it's still water. We're just learning more about that water. So a chemical property, kind of the opposite of a physical property, is a characteristic that can only be observed when you change the material into something new. So for example, if you were to burn a piece of wood, you would notice that it's actually turning into a new material, right? That black char is on the wood is not the same as the new fresh wood that you originally started with. So for this reason, a material's flammability is an example of a chemical property, whether or not that material will burn. Something else, another chemical property, is its reactivity. So for example, whether or not a material will rust or tarnish when it interacts with the air around it. An element, definitely a word that we've talked about before. An element is a pure substance that cannot be broken down into a smaller piece. So an element is the smallest unit of matter, and then atoms are the way that we describe different elements. So we talked about the periodic table of elements. Each one of those elements, carbon, hydrogen, oxygen, etc., are made up of atoms. So atoms are the basic particle which elements are made up of. So then, moving on, a chemical bond is the force that different atoms are bonded together. So, for example, you've heard about H2O. That's two hydrogen atoms and one oxygen atom bonded together. Molecules are a group of two or more atoms held together by a chemical bond. So we have here O3, which is more commonly known as ozone. Ozone is a gas that's in our atmosphere, and it's made up of 3 oxygen atoms bonded together. So O3 ozone is an example of a molecule. Sort of similar to a molecule, it often gets confused, is a compound. A compound is another example of a substance that's made up of 2 or more different atoms, and this is what really sets it apart from a molecule. So, because CH4 has 2 different atoms, it is considered a compound, right? It has the C for carbon, 1 carbon atom, plus 4 hydrogen atoms, bonded together. So CH4 is more commonly known as methane. Methane is an example of a compound. So compounds can also be molecules, right? Because CH4, that fits this definition, 2 or more atoms held together. So that is true. However, O3 ozone is not an example of a compound because it's only made up of 1 type of atom. It's not made up of 2 different atoms. So compounds can be molecules, but molecules cannot be compounds. And so moving on, a mixture is made up of 2 or more different substances. So we have one substance, NaHCO3. This is more commonly known as baking soda. And C6H8O7, that is more commonly known as citric acid. So these 2 compounds are combined together in a mixture, and this week we will be actually using this mixture, and it's called Alka-Seltzer, which is a type of medication if you don't know, but you'll become more familiar with it this week. But anyways, these 2 compounds are mixed together to create a new substance called Alka-Seltzer. And now moving on, there's 2 different types of mixtures, heterogeneous and homogeneous. Heterogeneous is a mixture where you can see the different components. A good example of this is soil. Right, soil, if you were to look at it, you can see the individual parts, what it's made up of. It's obviously a mix of different components, whereas a homogeneous mixture, you can't see the individual components. So a good example of this is brass. Brass is made up of zinc and copper. If you play a brass instrument, or even if you don't play a brass instrument, I'm sure you know what brass is. It doesn't look like it's made up of 2 different things. It just looks like one material. It's not like you can see the individual parts, but however, it's not found naturally. It's combined with zinc and copper. Another even more common example of this of a homogeneous mixture might be hot cocoa, which is made up of milk or water and cocoa powder and sugar. And if you make hot cocoa right, once you heat it up and stir it all together, you cannot see these individual parts and pieces. That's because the sugar and the cocoa powder get dissolved into the water, so as you're drinking it, it just looks like one material all blended together.